section R6, we are going to be talking about what's called rational exponents. Here's that expression rational again. Remember, rational just means fraction. It could be written as a fraction like 1/3, or it terminates, right? So when we have rational exponents, there are some rules we'll get into in a little bit. First, I wanted to do a little bit of a review and diving further into this. One of the rules we've talked about is a to the negative exponent is a reciprocal, a to the n. We called that the reciprocal rule. Now, I just wanted to show you a few examples just to make sure that we're all clear on what this means. For example, if we have 4 to the negative second, we could easily just make this, put it over 1, and then drop this to the bottom. So this would just be nothing on top and 4 to the second. Now, when I say nothing, really like an imaginary 1's there. It's not 0. So the answer for this would be 1/16. What about if we had a problem like 2/5 to the negative third power? Now what we could do is one of two ways. We could take the reciprocal, make it 5/2, and then to the third power, which would be 125/8. Or what else we could do is distribute this -3 first. This would be 2 to the negative third over 5 to the negative third, giving us, this would go on top to get rid of the negative, this would go on the bottom. We get 5 to the third over 2 to the third, which is the same thing. So sometimes in math we have multiple ways to do a problem, and it just comes down to personal preference. What if we had x times y to the negative third power? We're multiplying, which means we could distribute. So this would be x to the negative third, 1 times -3, 1 times -3. And then we could bring these to the bottom. So we would just get x to the third, y to the third on the bottom, nothing on top. We talked about that just being a 1. What if the problem was just xy to the negative third? Well, how is this different from the last problem? Obviously the parentheses, right? It's really x to the first. So the problem is the negative y. That's going to go to the bottom. The x stays where it is. And that would be the answer. Let's practice a little bit more using the quotient rule. Now with the quotient rule, remember if we have the same base, the exponents get subtracted, right? So a to the 5th divided by a to the -8th would be what? Well, 5 minus -8 is 13. Just be careful. Sometimes people do 5 minus 8, but it's really 5 minus -8. Okay, how about this one? Let's say 25 r to the 7th, z to the 5th, over 10 r to the 9th, z. Let's do this one by one, right? 25 over 10, well 5 goes into 25, that's just 25 over 10 is just 5 halves, right? R to the 7th divided by r to the 9th, well 7 minus 9 is -2. 5 minus 1 is 4. So what this turns into is, put this over 1 and bring this to the bottom. So we just have on top 5 z to the 4th over 2 r to the 2nd. How about 12 p to the 3rd q to the -1st over 8 p to the -2nd q. Right? I mean, after a while, these are all kind of looking like the same thing. So 4 goes into 12 3 times, goes into 8 twice. 3 minus -2 is 5. -1 minus 1 is -2. So if we're going to write this all as just one big happy fraction, we could bring this negative 2 to the denominator, and we get 3p to the 5th over 2q to the 2nd. And then our last one, what about 3x to the 2nd to the negative 1st power times 3x to the 5th to the negative 2nd over 3 to the negative 1st, x to the negative 2nd to the 2nd power. So let's distribute. Just do one thing at a time, right? We'll distribute those. We'll distribute this power, right? So our power of a product. And we'll distribute this. So let's see what we have here. This would be 3 to the negative 1st, x to the negative 2nd, times 3 to the negative 2nd, x to the negative 10th, all divided by 3 to the negative 2nd, x to the negative 4th. So let's look at the numerator. Can we reduce anything on top? Well, yeah, we have 3 to the negative 1st times 3 to the negative 2nd. Remember, the commutative property of multiplication says it doesn't matter what order we multiply things in. So let's multiply those two 3's together. 3 to the negative 1st times 3 to the negative 2nd. We add those powers. This is 3 to the negative 3rd. X to the negative 2nd times x to the negative 10th is x to the negative 12th. And we'll finish this here. Same base, so we subtract negative 3 minus negative 2 is 3 to the negative 1st. Negative 12 minus negative 4 is negative 8. We take care of negative powers by bringing them to the denominator. We would have 1 over 3x to the 8th. Okay. So now let's talk about what are called rational exponents. So a fraction as an exponent, right? So that's like a to the m over n power. Well, there's two different ways we could look at this. One way we could look at it as the nth root of a to the m, or we could think about it as the nth root of a all to the mth power. Usually we use the second way, but it's just important that you understand both ways are fine. So what if I asked you to simplify say 4 to the 3 halves? So we don't need a calculator for this. According to the rule, the denominator is what kind of radical it is. This is just the same thing as the second root, or the square root of 4 to the 3rd power. Square root of 4 is 2, 2 to the 3rd is 8. Or we could do the square root of 64, which is 8, right? 4 to the 3rd. So some people can get a little confused because there's a few different ways to do this, but it is what it is. All right, so pick whatever way you like better. What about negative 27 to the 2/3? Well, this would be the cubed root. Now I don't want to do negative 27 to the 2nd power, even though that's true. I mean, negative 27 to the 2nd power, that's a huge number. I can't do that in my head. So let's put the 2 on the outside of the radical. We'll use that second definition. The cubed root of negative 27 is just negative 3. Negative 3 squared is 9. So you can see how much easier that is to do in our head. Third one, how about 27 to the 1/3 times 27 to the 5/3, all divided by 27 to the 3rds. So we have a combination of properties here. In the numerator, we're multiplying the same base, so I'm going to add 1/3 plus 5/3. 1/3 plus 5/3 is 6/3. Dividing the same base, so we subtract the exponents. And that one's a little bit different. How about 6y to the 2/3 times 2y to the 1/2. Okay, well 6 times 2 is 12, that's easy, right? But then we have y to the 2/3 times y to the 1/2, so we're going to have to add those exponents. And the way that we add fractions, it's not a big deal, we just get a common denominator. So 2/3, we could use 6 as our common denominator. So if we multiply top and bottom here by 2, we get 4/6 plus 3/6 would give us our answer 12y to the 7/6. We'll learn how to reduce this in the next section, but for right now that's good enough. Or, we could even write 12 times the 6th root of y to the 7th. We have a few different ways we could write it. It's just important that you're understanding what I'm doing right now. How about a little bit harder here? Let's say 3m to the 5/6 over y to the 3/4 to the 2nd power times 8y to the 3rd over m to the 6th to the 2/3 power. So let's just go step by step here. Power of a product, we're going to distribute to these exponents. 3 to the 2nd. 5/6 times 2 is 5/3. 3/4 times 2 is 3/2. And we'll do the same thing with this one. 2/3 times 1 is 8 to the 2/3. 3 times 2/3 is 2. And 2/3 times 6 is 4. Okay. Let's see what else we have here. 8 to the 2/3. Maybe I'll just simplify that off on the side here. 8 to the 2/3 is the same thing as the cubed root of 8 to the 2nd power. So 8 to the 2/3 is 2 squared, or 4. So really on top what we have is 3 squared times 4. So 9 times 4 is 36. M to the 5/3 y to the 2nd divided by m to the 4th y to the 3/2. Okay, so let's finish this up. We're almost done. Same base, we subtract the powers. So 36 times, and we're going to do 5/3 minus 4. And 5/3 is the same thing as, let's see, we can write 4 as 12/3. So we get negative 7/3. And then we have 2 minus 3/2, right? So power to power. 2 we could write as 4/2 minus 3/2 is 1/2. So just cleaning this up, we could write this. This is negative. We'll bring this to the bottom. We have 36y to the 1/2 over m to the 7/3. That's what that problem is. All right. Stay tuned for the next lesson.